So welcome to Friday. Just a few little minor announcements. One, this is about the halfway point of the trimester. So we've got 6 weeks left after today. Um, we will. The plan is we'll have one more unit that we'll cover, and that will take us to the end of trimester 2. So next week we'll finish uh, chapter 4 or topic 4, or however you want to think about it. We will have a quiz on the inequalities and graphing inequalities, and actually on the beginning of next week, we will do um, graphing systems of inequalities, which is kind of fun. And then, like I said, we'll have a quiz, and then we'll roll into the next unit. So that's kind of where we're at. So if you have work out from chapter 4, you want to make sure to get that done. Again, I think it's most important. I would focus right now on 4-5, which is what we did on Tuesday and what we're going to do today, because our quiz next week will be on 4-5 and 4-6. If you're caught up with 4 or 5, then go back and pick up anything else in chapter 4. But make sure you have 4, 5, and 4-6 done before we take our quiz. Excuse me. All right. So on Tuesday, we graphed linear inequalities that were in that slope-intercept form. And to me, that's kind of the easier of the two methods. Today, we're going to look at what happens if we get a linear inequality that's in standard form. And we really have two choices. We can either find the x and the y intercepts and graph the line from there. And then there's a method that we can use to determine where we should shade. Or we could rewrite the inequality so it's in that slope-intercept form, the y equals mx plus b form. So just a quick definition. Standard form is the form ax plus by equals c, where both a and b cannot be 0. Because if they were both 0, then we'd have c equals 0, and that's not, we wouldn't have any variables, so we wouldn't have a line at all. All right. So, graphing lines in standard form. So one method, sometimes it's called the cover-up method. So to find the x-intercept, you let y equals 0 and solve for x. One way to think about that is you cover up the term with the y and solve for x. And we'll look at this with our examples. So you'll get a point, whatever your x coordinate is, and 0 for that intercept. Then you find the y-intercept by letting x equals 0, or you cover up the x term and solve for y. And then you would plot the x-intercept and y-intercept on the axis and connect those 2 points with a line. Again, the other method would be to rearrange the equation to get it in the form, I thought I changed this, but I guess I didn't. To get it in the form y equals mx plus b. In other words, getting the y by itself, and then graph the line using the y-intercept and the slope, and using the inequality to tell where you would shade. So what we're going to start with is just an equation. So there'll be no shading on the first two examples. And then we will move into the inequalities. And we're actually going to use the same equation, and we're going to do both methods, just to show that really the method doesn't matter. You get the same line. So whichever one you're more comfortable with, you can use. So this first example, we are going to graph using the intercept method. I like to call it the cover-up method, just because that's kind of what we're doing. So what I like to do is I like to just, I draw a little box on my smartboard because I think it shows the cover up a little bit easier. So we're going to start by finding the x-intercept, which is the point where y is 0. So we cover up the y term, and we solve what's left. So we have 3x equals -12. And if you're in standard form, when you do the intercept method or the cover-up method, you're always going to get just one term equals a number. To solve this for x, we divide by 3. X equals -4. So there's our x-intercept. Then we find our y-intercept. By plugging 0 in for x. Again, that means we're just going to cover up the x term. One of the things to remember, that minus stays with the 6y. So it's going to be minus or -6y equals -12. Solve by dividing. So 0, 2 is my y-intercept. I think one of the more common mistakes that I see when students try this intercept method is they want to graph the point -4, 2. But that's not part of our graph. It's -4, 0 and 0, 2. So just be careful with that. We're finding 2 points, not just one. And when we graph, there's our line. So that was using the cover-up method, or finding the intercepts. One of the things that is nice, now we're going to do it by solving for y. And we should get a y-intercept of +2 when we write it in slope-intercept form. So we'll take a look at that, and then we'll compare the two graphs. So I'm going to switch to my red pen. So now we're going to solve 3x minus 6y equals -12 and get it in the y equals form. So I want to get rid of this 3x. I can do that by subtracting 3x from both sides of the equation. On the left, the 3x is gone. It leaves me with -6y. On the right, I cannot combine those terms because the 3 has an x with it and the -12 does not. So the only thing I can do is just rewrite that expression as -3x minus 12, which if you look, that's what I want. I want something times x plus another value. So I'm almost there. Now I need to get the y totally by itself. So I need to undo multiplying by -6. So I divide by -6. And on this side, I'm just going to divide each term by -6. So anything that's being added or subtracted gets divided by -6. This first, the -3x divided by -6, I'm going to take care of the numbers first. Negative divided by a negative is positive, and 3/6 reduces to 1/2. And with the -12 divided by -6, again, two negatives make a positive. 12 divided by 6 is +2. From here, I can graph my y-intercept. And my slope. So either up 1, right 2, or down 1, left 2. Either way works. And draw my line. Now what I'm going to do is show both the previous page and this page at the same time, just in case you didn't jot this down. But you can see both lines are the same, which is good because it's the same equation. We would expect them to be the same. What that means is you can use either method. So if you're not comfortable solving for y, you can use the cover-up method. If you're not comfortable with the cover-up method, you could solve it and get it in that y equals form, and you will get the same answer. All right, so when we have inequalities, we have a little bit more work to do. First of all, we're going to determine whether the boundary line will be solid or dashed. So remember, it will be solid if our inequality is greater than or equal to or less than or equal to, and dashed if it's only greater than or less than. Then we're going to graph the line that forms the boundary, either with the cover-up method or solving for y. One thing to remember, if you're using the get the y by itself, if you're using the method 2, if you divide by a negative number, then you have to flip the inequality. Anytime we divide both sides by a negative, we have to flip the inequality. The third step, the last step, if you use the cover-up method, you need to pick a point that's not on the line and see if it makes your inequality true. Again, there are some points that work better than others, and I will talk about that when we do the examples. But if that point that you chose is a solution, if it makes the inequality true, shade on the side of the line that that point is on. If it is not a solution, you shade on the side that that point is not on. So that can be a little bit confusing, and I understand that. If you use method 2, you can use the same kind of shortcut that we used on Tuesday. If it's less than or equal to, you shade below. If it's greater than or equal to, you shade above. So if you do the cover-up method, you can't just go by what the inequality is, because there could be something going on that would cause that inequality to be flipped if you would solve it for your y equals. All right. So for me, I would solve for y only if y had a coefficient of 1 or -1. Otherwise, I would probably use the cover-up method. So this first example, I'm going to use the cover-up method. So I am going to find the x-intercept. By setting y equal to 0. And I should I think of what I'm going to do is I'm going to first think of this as 3x plus 5y equals 15 to find my intercepts. And then I go back to the inequality to check for my shading. So now I cover up the y term and I solve 3x equals 15. Divide by 3. I get x equals 5. Then I'm going to find my y-intercept. So x is 0. So I get 5y equals 15. Divide by 5. Y equals 3. If I graph that line, and I know that that line should be solid because of the equal to part. If it was just less than, it would be a dashed line. And now for shading. So pick a point that's not on the line. Whenever possible, I'm going to pick the point 0, 0. And you'll see why in a hurry, why that's such a good point to pick. So I plug 0, 0 into my inequality. So I get 3 times 0 plus 5 times 0 is less than or equal to 15. When I multiply this out and add it together, I get 0. That's why I like using 0, 0 with standard form. And is 0 less than 15? You can answer that one. I think 0 is less than 15. I'm almost like 99.999% positive. So we shade on the side that 0, 0 is. So we shade on this part. And there is our solution. Now, I shade the whole thing in. You could certainly just like use a pen or a pencil and just kind of draw shading marks like that. It's up to you. I will say for systems of inequalities, which we're going to do on Tuesday, having a couple different colors is always a good idea. All right. So in this case, my y has a coefficient of -1. So I think it's going to be easiest to solve this one to get it in the y equals form. You could still use the intercept method. It would work. I just want to show you the y equals method, or solving for y. Technically, it's not going to be equal to, but so if I want to get the y by itself, I subtract the 2x. So this is method 2. The 2x's cancel. So I have minus y is, I should say they cancel on the left-hand side. Minus y is less than -2x minus 4. Now I need to get rid of that negative in front of the y, so I'm going to divide everything by -1. Because I divide by -1, my inequality becomes greater than now instead of less than. So if the coefficient of the y is negative, when we divide, we're going to switch our inequality symbol. On the right-hand side, the -2x divided by -1 becomes +2x, and -4 divided by -1 becomes +4. Now it's in that kind of slope-intercept form. So I graph the y-intercept, and I use the slope up to right 1 or down to left 1. Looking at my inequality, is my line going to be solid or is it going to be dashed? Go ahead and either unmute and shout it out, or you can put it in the chat.
Dashed.
I agree. Yeah, excellent. So it's going to be a dashed line. So I'm going to draw my line as a dashed line. And because I solved it, I got it in that y equals form, I can just use the inequality to tell me where to shade. So I'm going to shade above. And there is my solution. So what I'm going to have you do is I've got a couple more examples that I want you to try, and then we'll come back and take a look at the solutions. So there are actually two. Rather than trying to put it on two screens, what I'm going to do is copy this one and paste. There we go. So there are your two inequalities. Again, if you have your packet, they are listed on page 21. I'm going to give you about 5 minutes. You can use either method, and then we will take a look at answers. So let me set up my timer. And mute myself so you don't have to listen to me anymore. So we're going to take a look at the solutions here, and what I would like you to do is tell me which method you used to solve this first example, or which one would you use? So go ahead and, there we go. Excellent. And then I will solve it in that method. Four more people need to vote. You have 15 more seconds. So there's still 3 of you that haven't voted yet. Maybe I should have added a third option with and I don't know option, but I don't want you to guess I don't know, because, all right, so by 1 vote, the cover-up method wins. So we're going to cover up and find the intercepts. So again, I think of this as x plus 3y equals -3 to get my boundary line. Find my x-intercept. So I cover up my y value. There we go. So I get x equals -3, kind of nice. I don't have to do any work. I already have my value of -3. My y-intercept, cover up my x term. So I get 3y equals -3. Divide both sides by 3. I get y equals -1. Is my line going to be solid or dashed? Dashed, correct. So I want it blue. I think it should be dashed already. Again, with these, I like to draw and use up all of the grid that I have, rather than just as little as possible. Personal preference. Pick a point. I'm going to pick 0.00. I should say pick a point that's not on our line and see if that inequality is correct or true. So if I plug 0 in for x and 0 in for y, I get 0 is greater than -3. True. So I can shade the side that 0, 0 is on. So even if you did the solve for y, the y equals method, your graph should look exactly like this. Minus maybe all of the blue highlighter that I used. But should be a dashed line. So your slope, if you did the y equals method, your slope would have been -1/3, and your y-intercept would be -1. All right, questions? All right, let's take a look at this one. Again, I want you to go ahead and tell me which method you used. And if you didn't use a method, then pretend you did. Which one would you use? All right, 10 more seconds. All right, so the cover-up method wins again. And actually for both of these, it probably is the method I would use, because again, that y term has a coefficient other than 1 in front of it. All right. So again, the cover-up method, I think of this as the related equation find my x-intercept by covering up the y. So we get 5x equals -20. Divide both sides by 5, x equals -4. And then to find the y-intercept, plug 0 in for x, or cover up the x term. Don't forget the negative. -4y equals -20. Divide by -4. My y-intercept is at 5. So -4, 0, 0, +5. Draw my line. Is my line going to be solid or dashed? Excuse me.
Solid.
All right. I agree, solid. So draw a solid line. Um, so there's my line. Now I want to pick a point not on that line, like 0, 0, and see if my inequality is true. So if I take, I'm going to need a little room down here. 5 times 0 minus 4 times 0 is greater than or equal to negative 20. I get 0 is greater than or equal to negative 20, which is true. So I'm going to shade below my line. So this is one of those cases where even though in the original inequality, it's a greater than symbol, my solutions are below the line that I drew. All right. Any questions? All right, so it's time to meet in some breakout rooms.